Hello to UILCS coders. In this video, we're going to cover the linked hash map data structure. So what is a linked hash map? A linked hash map is a hash map that maintains insertion order. So as you can see, I have an example of the hash map that we know, wherein each of these linked lists and entry is stored. The only unique change is that each entry, so I'll just, each entry contains a before and after value along with the key and value. So before will point to the entry that preceded it, or entry that came before it, and after will point to the entry that was inserted right after the element. Okay. So when you're looking at a linked hash map, I want you to look into as two separate structures. This and then this. So here I have a bunch of entries. They're all chained together, right? How are they connected with the before and head pointers that an entry has, right? So it's more like a doubly linked list. So let's do this. I'll add in my pointers. So when we have this kind of like separate sort of data structure, you can almost look at it like. And essentially when we add an element, right, it'll be in any of one of these buckets. But in terms of here, it'll be the new tail, right? Because the previous after pointer, so maybe let's just after, the previous after pointer will point to this new element that we've added in. And then conversely, its before will point here, so this would be before. So don't got room for all before. But yeah, that's essentially the linked component. We're just using before and after as pointers. So it's kind of two data structures in one. Of course, we have the hash table like hash map. And then you can also view it like this, like a linked list, where each element is just linked by the before and after pointers. It's also why we can call it a linked hash map. Okay, there's only one new method, which is the remove eldest entry. So the remove eldest entry will, so let's write it here. It returns true it returns true if size limit reached. Now, the reason I'm saying size limit and the reason this method exists is to create an LRU cache, or least recently used cache. So, what is a cache? A cache stores, and this is like, this is like important, not important to UIL, so you can skip this if you want. A cache stores data. Particularly, we can make it a data structure that'll store in previous returns. And then, so what we can do here, let's say we have a recursive function, right? That'll repeat over and over again. And then if I pass in 10, then we get a recursive function 9, then a recursive function 8, and so on and so forth, right? It'll do the math, whatever, we said base case, whatever. The point is we get some value from 10. And if I were to do recursion 11, well, then, okay, we can do recursion 10 and then recursion 9, but that's slow. That's slower. So alternatively, what we could do is in each of these recursive calls, we can add output or add the return to our LRU cache. And then here, instead of doing rec 11, so we'll do rec 11, we check if this key 11 is in our cache. So it might even need to be a dictionary, maybe. Anyways, it all actually would be a dictionary because the whole point is we're turning this into a dictionary. We would go to rec 10 and we check for that 10, we see its value, right? So key 10, its value is it's returned. It returned this, so then we simply just go here, return that, and then boom. Life is good. This was only 2 steps, this was how many, so on, right? That's something what the LRU cache does. We call it the least recently used cache. Yeah, okay. So the LRU cache will store all the elements that we've least recently used. So let's say for instance, in this recursive function, or let's say just normal, right? Least recently used, let's say I'm getting 10, and then I'm getting 9, and I'm getting 8. I don't know, 9, 10, 8, whatever, they have keys, right? Point is these keys are being used, so they're being accessed or used. So we're gonna store the value on the LRU cache. The reason we use an LRU cache, you can see maybe in this example one in terms of data structures, is because still going through this system and finding the keys takes some time, right? Finding the entries, right? If we say it's O1, it's not exactly O1. But with this caching system, well, hey, it's basically saying these people are using, modifying, looking at some certain key value pairs over the others. Or let's take all the key value pairs that this person's looking at the most recently, and then store them in some data structure, and then remove eldest entry. What does that do? Return true if size limit reached. Okay, so we've added 10's result, we've added 9's result, we've added 8's result. Let's try and add 7's result. Well, if we keep on adding results, right? If we keep on adding whenever they call get, which will just say is them accessing the element. For simplicity, we'll have an infinite array, or it won't matter, it won't do anything, right? We need some cutoff point to say, hey, after this, once you've reached here, the oldest element, the one that was least recently used, 10, should be removed because it's old now, right? And we only want to store the new, most recently used elements, you could say. So that's what I mean by size and why I didn't say capacity, why I said size limit. Because you can define, let's say I want my size limit to be 3. Okay, size limit is 3. Uh-oh, I'm adding in 7 now, right? I just added in 7. We've resized limit, or we've gone past it. So then we'll simply just delete 10. And now we'll be left to 9, 8, 7. That is the LRU cache. And then, well, how does it know that I want to do it by getting, right? What is this getting? We call this, I said accessing, right? This can be referred to as access order, right? Your hash linked or linked hash map does not just have to do insertion order. It can be insertion order sorted, or it can be access order sorted. So when we do access order sorted, then what is that? That's this. That's the LRU, right? That's just calling get and getting this. And then we can just use the remove eldest entry to check if we've passed some size to delete the head of our, would it be head? Yeah, delete the head of our cache or our linked hash map. So you can essentially just take this linked hash map and make it an LRU cache. So insertion order or access order. And how do we set this? Well, we set this up in the linked hash maps constructor. So I'll just write new linked hash map. You can pass in 3 things to this. You can pass in the capacity. You can pass in a load factor. And then you can pass in your order. So order is a boolean. If you do true, it'll do access order. If you do false, which is also the default, it'll do insertion order. Capacity is the capacity of the array. Load factor might be weird. It's a float. It's a percentage, right? So it's gonna be a float we use. Oh my goodness, bro. It's gonna be a float from 0 to 1. And it will be either, or it basically just represents, hey, float 0 to 1 at this size. So maybe like when we're like 0.7 float, so 70% of 2 capacity, resize. Well, the sensors will just never reach capacity. That's nothing to worry about. Order is the most really important one here, right? False insertion, true access. When you're accessing, it's getting. So it could also be other operations like maybe compute, merge, etc. Whenever you're really just looking at keys, we call that accessing. But in my example, I'm just using get as accessing. That's the linked hash map. Everything again is O of 1, right? All the operations are still the same. All time complexity is still the same. One last thing, maybe you might wonder, okay, how does this insertion order work? I know it works with this linked list kind of data structure that we can make using the before and after pointers. Well, how does that get printed out, right? When we go to toString, we'll start at the head and then just print out following the after pointers. That's it. That's it. I mean, it's a linked list. That part's just linked list. You know that. I just want to bring that up because I don't know, I thought it might be important. We're not gonna bother with making a linked task map. I don't think UI will ever show you a linked task map because they couldn't really, because the way you code a linked task map is you have to modify HashMap itself. HashMap will have more functions like that handle this portion, doing all this stuff that just are technically called in a hash map, but you just don't do anything because it's a hash map, not a linked hash map. Linked hash map will have its own like special overridden version that will actually do stuff. But yeah, so that's where we're gonna leave it off for this. I covered everything that's important, but most of this is yeah. I don't even think you need to know this stuff. Like hash maps are really easy. Just know this, and just really no, just know this. It's a maintain insertion order. Maybe they could do something in access order. Maybe, which is why I mentioned it, but I don't think they're likely to do that. But yeah, that was it, guys. Hopefully you enjoyed the linked hash map video.